Hey everybody, I wanted to do a couple more examples of multiplying with imaginary numbers, and I wanted to do so with like distributing into parentheses and then also doing a binomial times a binomial. And if you don't know what that is, we're going to go over it. But let's imagine for a second I said what is 3i and then times let's say 5 plus I or something like that. Okay. So what you're going to do is kind of like, imagine this was 3x times, 5 plus x or something like that. You would distribute the 3i. So 3i times 5, and then 3i times I. All right. So 3i times 5 is just 15i. So again, you multiply it just like you would if it was an x. So that'd be 15i. And then 3i times I is 3, and this is where people will mess up, I squared. All right, so remember, I times I is I squared. Now, if you leave it here, you're not finished. So this is not complete. Because remember, and I said this in the last video, what is I squared? I squared is the same thing as -1. So really, this is just 3 times -1. And again, that's 15i. Well, what's 3 times -1? Well, it's -3. And we usually, well, I don't think it matters, but we put -3 and then plus 15i. And again, I apologize, for some reason my thing is glitching, so I'm doing this piece by piece. All right, so anyway, so that's what we do with that problem. Again, make sure your answer does not have any I squareds or i's to the third or anything like that. You have to simplify it so that you have a real part and an imaginary part. So here you have, let me change color here. So with this -3, that's the real part, and then this is called the imaginary part. And this right here, I'll just go ahead and say, and again, we talk about this in class, but this is called a complex number. And this is really hard to write with it glitching, sorry. Complex number. So, and a complex number has a real part and an imaginary part. Now, every number really is a complex number. So if I wrote 3 is a complex number because it could be written as 3 plus 0i. Meaning your imaginary part is just 0. So any number is really a complex number, but I just wanted to make sure you kind of understood that. All right, but let's do one where it's a binomial. So let's imagine, and this will be the last one I do here. Let's see, let's do 2i minus 1. All right, it's not working, there we go. All right, and we'll say 3i plus, we'll do 7. So I just made this up. All right, so if you remember how to multiply a binomial times a binomial, basically every single term here, so these two terms, multiply by both terms in the second parentheses. So it'd be 2i times 3i, which is 6i squared. And then 2i times 7, which is just 14i. And then -1 times 3i, which is -3i. And then -1 times 7, which is -7. Okay. So if you look here, this kind of looks like a quadratic. So you have a square, and then you have like terms here, and you have 7. We can go ahead and combine the like terms. So 14 minus 3 is 11i. And again, we talked about adding and subtracting imaginary numbers before. But also remember, what is I squared? I squared is -1. So this is really just like 6 times -1, which is -6. So I'm going to bring down the -6. So -6 plus, and then bring down the -7. Now again, I'm still not finished because I do have like terms here. I have the -6 and then I have the -7. If I put those together, I get -13. And then also the 11i. So you're working it basically the same way you would if you were doing a binomial times a binomial with an x instead of an I, but it's the same process. Again, I hope this helps. If you do have any more questions, please let me know, and I would love to, be willing to make another video.